All right, so reviewing multiplying and dividing rational expressions today. This is nothing new. We did this in Algebra 2, but here we are reviewing it again in Algebra 3. Step 1 is to factor everything. So all four pieces of my two fractions need to be factored. So step 1, c squared minus 2c. Remember, the first step is always to look for greatest common factor. So we would start by dividing out the c, which leaves us c plus 2. Underneath that, c squared minus 4, that's perfect square minus perfect square. So that's going to follow the pattern c plus 2 and c minus 2. Splitting up the c's, splitting up the 2's. Beside that here, c squared minus c, they have c in common, so that's the greatest common factor, leaving c subtract 1. And up here at the top, there's 1 in front, so we can just take the shortcut for factoring. We don't have to use AC method because the factors of 4 that can add up to be 4, negative 4, sorry, are going to be the same, because if we do just working at the end, or with the 1, because 1 times 4 is still 4. So the numbers that can multiply to 4 and add up to be negative 4 are a pair of negative 2's. So everything is factored completely, and now I look to cancel out any factor that is divided by itself, because anything divided by itself equals 1. So this c divided by that c would equal 1. It doesn't matter which fraction it's part of, as long as it's in 1 in the numerator, 1 in the denominator. They pair up and cancel out. So this c plus 2 with that c plus 2. And one of these c minus 2's with the other one on the bottom, one of them will still be there. So our answer is just going to be the factor c minus 2 left in the numerator, and just the factor c minus 1 left in the denominator. And we don't have to do any multiplying, we just leave it like that. Remember, you cannot cancel out any further. You have to keep the entire factor or cancel out the entire factor. You can't get in here and start messing out with the middles of the factors. So c minus 2 divided by c plus 1, minus 1 is the end of the row. Okay, so what about dividing? Down here at the bottom is a division problem. Dividing is going to be thought of as changing it to multiply by the reciprocal of the second fraction, so that then we can use our multiply steps, which were factor out all the pieces, do our cancellations, and see what we have left. All right, so here's my divide. That's going to change to multiply, and this is going to be the reciprocal. So I'll have x minus 5 times 9x squared minus 18x times 2x squared minus 5x plus 2 moves to the numerator, and 2x squared minus 11x plus 5 moves to the denominator, because we've made the reciprocal there. All right, so x minus 5 is factored. No GCF, no powers, nothing to work with. Underneath it, 9x squared minus 18x. There's a greatest common factor, right? Both of those numbers divide by 9, and both of them have at least one x. So x minus 2. Over here, now we're going to have to do AC method, because there is a 2 in front of my x squared. So off to the side here, 2 times 2 makes 4. The two numbers that can multiply to 4 and add up to negative 5. 4 and 1 make 5. If I make them both negative, I still can multiply to a positive number, but add to a negative number. So let's start up here so I have a little space to work. 2x squared, we're going to substitute in minus 4x and minus 1x to replace this negative 5x, plus 2. I'm going to split that down the middle and take out the greatest common factor of the first pair, which is the 2x, leaving me x minus 2. And over here, if I also want to have x minus 2, then I would divide out the negative 1 to change the signs. So pull together the 2x minus 1 and write one copy of the x minus 2. Okay, underneath, 2 times 5 makes 10. Finding the factors of 10 that can add to 11. 10 is either 2 and 5 or 10 and 1. If I need a negative 11, I'm going to use the 10 and 1, but again, I'm going to make them both negative. So they multiply to a positive number, but add to a negative number. I'm going to leave space for my answers right here, so I'm going to start the problem down here. 2x squared. I'm going to substitute in minus 10x and minus 1x in place of the 11, plus 5. I'm going to split it down the middle and take out the common factor, which is both numbers divide by 2 and x. So it leaves x minus 5. And over here, if I also want to leave x minus 5, then I have to pull out a negative 1. So 2x minus 1 pull together, and x minus 5. Alrighty, so let me highlight the things we're looking at here. We have these factors, these factors, these factors, and these factors. And we're looking to cancel. So I can see this x minus 5 divided by this x minus 5 would be 1. I can see this x minus 2 and this x minus 2 would be 1. And this 2x minus 1 and that 2x minus 1 would be 1. So in the numerator, all my factors canceled out. So I'm going to put a 1 multiplied by 1. I wouldn't need to see that, but it needs to be there to hold the fraction bar down. And on the denominators, I only have this 9x left over. So we have 1 over 9x is the answer to our division problem. All right, give it a try and ask questions if you need to follow up.